Okay, what I want to do is I've kind of written this out already, and I want to just take you through the steps on how to get these phasors taken care of, the adding and subtracting of them. So keep in mind that a phasor is part of a circuit as part of the sine wave. You don't need to know any of that, but it's kind of giving you your overall measurement as far as voltage, impedance, things like that in a circuit. You don't need to know that. What you need to worry about is that the phasor itself is the hypotenuse in a right triangle. Now, the way they draw it on your questions, they give you part of the coordinate plane, and it looks funky because they got all these arrows drawn, stuff like that. But what I can tell you to do is, based on the location of the phasor, you just draw your right triangle. Like I showed you back for the RC and RL circuits, you draw your right triangle, you label your hypotenuse, you label your angle. This is the phasor for Z2. So, how do I know which quadrant it's in? Well, you go by the sign of the angle, or you go by the sign of the y coordinates. So it's either going to be in this quadrant or this quadrant. So what we have here is we have a hypotenuse of 2 at an angle of 16 degrees. So that's how we draw it. We rotate the angle. There's my hypotenuse. There's my angle. Make my right triangle. And what I need to do is I need to find the rectangular coordinates. Because in order to add or subtract the phasor, you have to use the rectangular coordinates. So the x coordinate can be found by taking the hypotenuse times the cosine of the angle. The y coordinate can be found by taking the hypotenuse times the sine of the angle. So I kind of got ahead of myself there, but your x is 2 times the cosine of 16, which you should get 1.9225. I'm rounding to 4 decimal places just because I don't want my final answers to be off by a tenth or a hundredth. So make sure you carry these out as far as you can until you get to the final answer. They'll be more precise that way. It'll save you the frustration of wondering, why do I keep missing these by a tenth? Y is 2 times the sine of 16. So that gives me 0.5513. So then I create my rectangular coordinate for Z2 by saying x is to the right this far, 1.9225, and I'm going up j. J is just the indicator that you're in a circuit, okay, of 0.5513. So there I have my rectangular coordinate. Now I have to find the rectangular coordinate for Z1 because, see, I'm taking Z2 minus Z1. Excuse me. So Z1, again, is a phasor, and I have a hypotenuse of 1 at an angle of 39 degrees. So again, I'm rotating counterclockwise when the angle is positive. If the angle is negative, you rotate clockwise. That's why it's down in this quadrant if it's negative. Do the same thing. Now, the good thing about having a hypotenuse of 1, 1 times the cosine of 39 is just the cosine of 39. Same thing with the sine. So x is 1 cosine 39, which is 0.7771. See, again, I'm carrying things out to 4 decimal places. Y is 0.6293. So I have now my rectangular coordinate for Z1. So this is a tedious process. But, if you want to get these correct on the test, you'll just have to go through it. The problem is you kind of forget where you are. Trust me, after you go through these. So, just realize that what you've created is 2 right triangles, and you found all the measurements of each one. Okay, that's our goal, is to know the rectangular coordinates as by x and y, and the hypotenuse and the angle of rotation. All right, so we found Z2 rectangular, Z1 rectangular. So you know these are the rectangular coordinates. And you've been doing rectangular coordinates your whole life. It was back in elementary school when you started plotting points. Over and up, over and down. Those are rectangular. Why do they call them rectangular? Because when you move, you form a rectangle. Okay? All right. Now we're going to look at subtracting them. So I subtract Z2, which were these, minus Z1, which are those. So we got those set up. And keep in mind, when you're subtracting, you have to make sure you subtract the first one and the second one. So therefore, in theory, we're changing both signs. So that becomes a minus 0.7771, and that becomes a minus 0.6293. So if this were minus here, it would become a plus. So you got to watch your signs, because if you go through this whole process and you miss a sign, you're not going to really understand what you did wrong. So pay attention to your details. Okay, that's what math teaches you, how to pay attention to details. So then I subtract, and I come up with my rectangular coordinate for the Z2 minus Z1. So my x is still positive, but now my j is negative, which tells me I'm down here. I am now down here for my phasor. Okay, so it is this triangle, kind of like the RC circuit down here, where this is my x, this is my j, or as we say, y. All right, so now I'm going to have to find the hypotenuse and the angle. So I do that just like we've been doing on every trig equation, right triangle so far. Now what I do, because I know what happens, I've been teaching this class for many years, this is a negative 0.078, and what happens when people calculate using Pythagorean theorem, they mess up and they don't square this negative properly using their calculator, because you got to put it inside parentheses and before you square it, and then they end up subtracting here. So what I always tell my students to do on my on-campus classes, just make it positive. Why can I do that? Well, when I square it, it's going to become positive anyway, so it doesn't matter how you enter it. It's going to be positive. That'll save you the problems. Then I go ahead and square both of these. This is what I get. Add them together, and then I take the square root. I'm still rounding to 4 decimal places, because what you can see is that R, if I rounded these to 2 decimal places, they would both be equal, and that you can't have that in a right triangle. So I use 1.1454. This is 1.1481. They are very close to each other. So if you rounded too early, you're going to have problems when you use your trigonometry. So round to 4 decimal places. It's not going to kill you. All right. That may give you a headache, but it's not going to kill you. Okay, so I found R. Now I'm going to find the angle. So again, when finding angles, you look at the angle and say, okay, that's my reference angle. I do know all 3 sides, but since I've already have the opposite and the adjacent listed, I'm going to go ahead and use the tangent. So opposite divided by adjacent implies we use tangent. So that's what I do. So I got negative 0.078 divided by 1 point, and you probably can't see my decimal point here, 1.1454. Divide, and again, I'm rounding to 4 decimal places, and that is negative. Even if you use the other ratio and did not use the opposite side, just know that since we do have this triangle here, this angle must be negative because it's down here in the fourth quadrant. So if you leave off a negative sign, you're going to miss it. Okay, just a lot to remember. A lot to remember. All right, so what I end up with is, once I do tan inverse of the negative 0.0681, I get negative, I think on my calculator I got negative 3.895, but I'm rounding to 2 decimal places. So 3.895 rounds to 3.90, depending on what you're asked to do on your answers. If it's 2 decimal places, you may want to throw that 0 in there, just because the software is sensitive, okay? And so I went ahead and rounded my R as well from 1.145 to 1.15. And it's intriguing to me how we still have trouble rounding. You know, that's something you learned years and years and years ago, but we still have trouble. If I'm rounding to 2 decimal places, that means I'm rounding to the 4. I look to the right. If the number is 5 or bigger, I add 1, because that means it's closer to 0.15 than it is 0.14. If it's less than 5, I leave it alone. So, you know, review your rounding. So there you go. That would be your answer for your subtraction of your polar coordinates. So it's a long process, but it's all about finding measures of right triangles. If you understand how to find these measures of right triangles, then hopefully this will make it a little easier for you to get these, because you've been doing that already. It's just a different process as to how to find these phasors. All right, so again, I know the exam is due tomorrow, I believe. I'm going to extend it a day because I have been out of town due to a death in the family, an unexpected death in the family. So I had to drive to Pennsylvania. So I've been kind of off the grid for a few days. I apologize for that, but things happen. So anyway, so I will extend it a day, give you an extra day to prepare. Good luck.